If you're writing the 2025 UTME, you're likely to come across this question, which is under the topic of optics in waves and optics. So specifically, this one is under the image formation on spherical mirror. And I'm going to cover it a little bit here, but these are questions that you necessarily don't even need to calculate. Now, it's okay if you calculate, but understanding the concept of image formation can help you to solve these questions alone. Let's try this number 2 that you might think I'm going to calculate. Now look at this. A ray of light passing through the center of curvature of a concave mirror is reflected by the mirror at where? Now I'm going to take you through the subject of image formation in order for you to understand what we're doing here, and you see that you are going to be able to attempt it by yourself. Now, a concave mirror of radius of curvature 40 centimeter forms a real image twice as large. Now, you must understand the concept of real image here. So let's underline that. As the object distance is now what? Okay. Now let's go back the image formation on the concave mirror. When is the mirror concave? The mirror is concave if its outer part is shaded here. The outer curvature is shaded, and then you have the. So it means that if I have a mirror that is facing like this, and I shade this part, it is still what? Concave. You understand? The main thing is that it is this outer part that is shaded. All right, so that's concave. Now, we always draw what is called a principal axis through the middle or center of the mirror. The mirror has the following points. This is a concave because of this part is shaded. It has the following points. The midpoint here of the mirror is called the pole. Now, the radius, because this is a sphere, right? And the sphere has its own radius, right? The radius by which this thing was constructed is called the center of curvature for a mirror like this. For a lens, it's called radius of curvature. For a mirror, it's called center of curvature. And midway between the center of curvature and the pole is called the focus. It's called the focus. Now, here are some rules that you should know. When you draw a ray of light to be parallel to the principal axis, by the time it will be reflecting, a mirror always reflects a ray. Is that okay? Now, contrary to a plane mirror, if it's a plane mirror, if an incident ray, which is the ray coming from the source, touches the plane mirror, what should happen is that it should be reflected at the same angle as the angle of incidence. And recall, the angle of incidence must be read with respect to the normal. Is that okay? Okay. So we now have that. What if, but for the case of spherical mirror now, it's not like that. If a ray of light touches it, the angle of reflection is not equal to the angle of incidence. Does that make sense? So it is such that if a ray of light touches it in parallel to the principal axis, in the direction that is parallel to the principal axis, it should be reflected off in a direction that is towards the focus. It must pass through the focus. This is incident ray, this is reflected ray. It is reflected towards the focus. But if you now draw a ray to pass through the focus like this, you draw a ray to pass through the focus like this, and it touches the mirror. By the time it will be reflected in a direction that is parallel to the principal axis. If you look at it very well, it is just the direct opposite of the initial law. Does that make sense? And that's because of the principle of reversibility of light. Principle of what? Reversibility of light. That light is reversible. Is that okay? Now, that proves it. And the third law that you must know is that there are 4 of them, but it's only 3 that is very advisable to use. Now, then you know that there is a center of curvature here, which I said is double the distance between the focus and the pole here. Now, a ray of light that you draw to pass through the center of curvature like this will be reflected back in the same direction. And that is very important. A ray of light that you draw to pass through the center of curvature will be reflected back in the same direction. And why is that so? It is so because on a plane mirror, for example, if a ray of light is reflected at an angle, it is incident at an angle, we expect it to be reflected at the same angle, right? So if this was theta should be equal to theta on both sides, right? And this incidence is reflected. But when will a ray of light not have an angle? It is only when it is coming towards and directly from the normal. Does that make sense to you? It means that if the ray is passing, is coming from the normal exactly, it will go back through the normal. The ray of light comes through the normal, it goes back through the normal. So the same way here, the reason why it is going back through the line that you drew from the center of curvature is because the center of curvature is the normal to the tangent on every point of this curve. I repeat that, I said the center of curvature, the line that comes from the center of curvature is the normal to the tangent drawn at any point of this curve. All right, that's the case. Good. So having understood that, let's answer the first question. The first question says that a ray of light passing through the center of curvature of a concave mirror is reflected by the mirror at what angle? It comes through this angle. At what angle will it be reflected back? Will it be reflected at any angle? That is on angle what? 0 degrees. Does that make sense to you? 0 degrees. Right. Now, a ray of light. Okay, yeah, we've done all the rules for drawing image, for image formation. Now, watch this. If I put my image, I'm going to use only this guy. If I put my object at this place, for example, that is at beyond C, at any distance away from C, away from my center of curvature. If I put my object, rather, this is called the object. What is formed by the mirror is called the image. Is that okay? Now the object here is placed at beyond C, that is away from C. We always read from here towards this direction. Is that okay? In my channel, there are 2 sign conventions that I taught, so do well to check on my channel. I'm going to go to my DM or the link in my bio, and you're going to see the channel name there. Or I could also link the video in the description of this video. Now, I said that this guy, if it's placed beyond C, how do we form the image? Now, we could draw a ray that is parallel to the principal axis, isn't it? This is the incident. By the time it's reflected, where will it be reflected towards? Towards the focus, right? So it's going to be reflected towards the focus. So this angle, this is the reflected ray. Now, we could draw another ray that will pass through the focus itself. Now, if we draw one to pass through the focus, by the time it will be reflected, how will it be reflected? Parallel to the principal axis, right? So parallel to the principal axis like this. Now, what do you see? Where the images, where the rays touch each other, where the reflected rays touch each other, that is where the image will be formed. So where they touch each other, this is the incident reflected. Incident reflected. So where the reflected rays touch each other, that's where this portion will be formed. And just join the remaining parts of the body to the guy. Now, what do you see of this image? What's the relationship between this? Compare this guy with this guy. In size, what do you see? The image that is formed first, it is a real image. It is what? Real image. Then it is an inverted image. It is what? Inverted. And remember, real and what? Inverted. Once it's real, it is what? Inverted. Once it's real, it will what? Inverted. And as it is, what's the size? Compare the size. Which one is bigger? Object is bigger, right? The image is smaller. So we say it is what? Diminished. Image is what? Diminished. Good. Now, what if we now place our object? You can also talk about the distance. Now, that makes sense. The distance from here to here is longer than the distance from here to here, right? So we say object distance, which is U, is greater than image distance, which is V. Object distance U is greater than image distance. I want you to take note of all of this. Now, for another body I have my center of curvature, I have my focus on my principal. If I put an image at C, an object at C rather, using the same principle, I draw my ray of light. Now it passes through this point. Is that okay? That is the reflected. Then I draw another one, incident, passing through the focus. By the time it will be reflected, it should be reflected towards the parallel to the principal axis, right? Now, if you look at it well, because my hand is not, I'm not drawing to scale, it is not exactly where it should be. Now, it should actually fall here. Anytime you place your object at C, you always form image at C. And that is because the C, as I said, is the normal to the curve, to the tangent, now normal to the tangent at every point on the curve. So we always form, and the image characteristics are also the same. We have that it is real, of course, it is inverted. Now note that any image that is formed in front of the mirror must be real. It is real, it is inverted, that is upside down, looking at it. Then you also see now, how about the size? Equal in size, right? Equal in size. So we say the size is what? The same. Size is same. Size is same. Is that okay? Now for the next one, now I might not be able to draw everything. I'll just, not like I might not be able to, I might not be drawing everything because of time. So I have this guy, my center of curvature is here, focus is here, focus is around here, and pole is here. If I place my object at this point, let me place my object at this point. Object at this point, the same principle applies. When you draw incident ray to come to be parallel to the principal axis, it passes through the focus. Does that make sense? If you draw a one to pass through the focus first, by the time it's coming back, it will be what? It will be, now this is not exactly very correct. It's supposed to really go far away from that side. Let us draw it well. If it goes like this, then you're going to have a ray of light that is also passing through like this. So let's draw our guy together. So by the time they meet, actually, they should meet at beyond C. They'll meet at beyond C because I'm not trying to scale. So you notice this. So what do you see? The image that is formed is what? Magnified, right? First it is upside, it is real, inverted and what? Magnified. So what do we see? We have formed a pattern. Read, reads, read. Do you remember? So we now have, I'm going to draw one more because of the space. So I have my center of curvature, I have my focus and the pole here. If I place my ray of my object, if I place it at F, what do I form? I place this guy at F. You will notice that I'm bringing the object close to the mirror, right? We always read distance away from the mirror. Does that make sense? So using the first principle, we have that a ray of light that is parallel to this will pass through the center, the focus. Now we cannot use, there is a fourth rule I did not talk about, and that is the rule of that a ray of light that you draw to pass through the pole will pass through the same angle, will reflect it at the same angle at which it is incident. It is because at that pole you have it always appears as if there is a ray coming from the what? Coming from the center of curvature, because the center of curvature is standing as the normal at that time. Do you understand? So there is a normal to the tangent that is drawn here. Does that make sense? So a ray of light that is passing through here should always be reflected at the same angle, reflected through the same angle at which it is incident. Does that make sense? So here you have this. So what do you notice? You are going to notice parallelism, right? So because they are parallel, they never meet, right? Image, of course, what it will form will also be inverted, real, right? Inverted and what? Magnified, extra magnified here. But actually, the magnification is going to be at what? Infinity. It's going to be formed as where? Infinity. So we have read, reads, re as we go towards the mirror. Now, having had this information, what do you notice? There's a pattern formed there. The only time we form a diminished image for a concave mirror is when we are beyond C. Does that make sense? When we are beyond C. Every other time, we see a what? A magnification. I mean, at C, we see same side, but once we go beyond C, I mean, once we go before C, that is closer to the mirror, closer to the mirror than C, then we see a what? Magnification. Does that make sense? All right. So let's see. Let's answer this question. Now, you are going to, if you have understood what I said here, you see that this thing will make sense. A concave mirror of radius of curvature 40 centimeter. If the radius of curvature is 40 centimeter, what will be its focus? Radius of curvature is 40 centimeters. Let me clean that first question. Radius of curvature C is, or R, either ways, is 40 centimeters. What will be the F, the focus? That what? Half of this, right? Which is 20 centimeters. It now says that forms a real image twice as large as the object. If it forms a real image that is large, it means the image is what? Magnified, right? Good. The object distance is what? If the image is magnified, it means that the object distance, okay, let me ask you a question. Will the object distance be greater than 40 if the image is magnified? No, because if it's greater than 40, it will be what? Diminished. If it's greater than 40, it means it is beyond C. Do you understand? So it has to be less than 40. So it means that we have streamlined our answer. Our answer can never be 60 and can never be 40. Now you are going to, those of you those in the online, you're going to be solving this and proving if it's wrong or correct. I'm going to see how it is. So now the next one says that, now the next idea is this. We now have two options left. It says it forms an image that is twice as large. Now take note of the word real. Take note of the word what? Real. The only time a concave mirror ever forms an unreal image, a virtual image, is when the object is placed between F and P. And let me quickly show you that. Let's place an object between F and P, and let me show you what it forms. So these are F example. This will be our C, that is. So now, if you place an object here, for example, you place an object here, you place someone here. Now, when you draw a ray of light to be incident at here, by the time it will be coming back, the ray of light, now if you draw a ray of light here, by the time it will be coming back, we don't want to draw something that will come through the center of curvature like this. Is that okay? We don't want to do that. There are two things we could do. We could draw a ray of light to come from the center of curvature to pass to the edge so that we know that it will be reflected via the same line, right? Are you with me? And of course, okay, here we can draw this to touch the center of curvature and pass through the focus. So what do you see? It looks like it's diverging, right? So let's see where it converges. It's going to converge at somewhere at the back. Does that make sense? So where they meet is going to be where our image will be formed. So this image, what do you see? It's also increased, but one thing about it is what is not real. It is what? Virtual. When you are virtual, you must be erect. When you are virtual, you must what? So it is virtual erect. Now, what do you notice? So what am I saying? Is that the only time you form a virtual image in this guy, in concave mirror, is when you place image between what? F and P. Does that make sense? Now, if you now, so let's analyze this now. 10 centimeters for our center, for our radius, center, our focus is 20, right? If you place image as 10 centimeter, where is that? Is that between F and P or between C and P? Between F and P, because 10 centimeter is less than 20. Does that make sense? So if the image is real, then it is not between F and P. The answer will be 30 centimeters. Actually, you don't need to go through all this. All you need to do is understand this. Once you understand this, I don't need to solve my book, touch my pen or paper before solving this. Do well to subscribe to the channel, and you can also comment in the comment section below whatever is not clear to you. God bless you as you subscribe to this channel or follow me on TikTok.